Hello everybody, what is up? Today we're going to be going over geometric probability, which is when you take a probability problem and you turn it into a geometric shape so that it's easier to find the solution to. I have two fantastic problems for you today. I'm going to head right into it. We have a point selected at random within a circle of radius 6. This is a geometric probability problem. I'm drawing that circle immediately. What is the probability that a point lies in the shaded area outside of the smaller circle of radius 4? Oh, so we have another circle with radius 4 over here. Immediately going to draw it. And we need to find the probability that it is between this 4 and the 6 centimeter radius circle. Now this problem seems a lot easier to take on. We just need to find the probability of the good stuff out of the probability of the whole stuff. And so to find the how much area there is over here, we're going to take the area of the bigger circle and subtract it from the area of the smaller circle. So we have pi 6 squared minus pi 4 squared. And then since we're comparing the area of this to the whole area, the area of the whole thing is going to be the area of that 6 centimeter circle. So this right here is going to be our solution. We can simplify it out to be 6 squared minus 4 squared over 6 squared, which equals 36 minus 16 over 36. Oh wait, 6 squared is 6 times 6, which is 36. What am I saying? Okay, and so this is 20 over 36. We can take out a 4 in each of these. So we have 5 over 9 for our final solution. Now this problem became a lot easier once we drew it out and really saw what we were doing instead of just looking at the problem as words. Now moving on to our next problem. This is the second type of geometric probability question that often comes up. We need to find the probability that two, not necessarily integer, numbers selected at random between 1 and 4 have a sum greater than 4. So if you weren't going to think of this as a geometric probability problem, you would probably just put in numbers at random. But then you see that it says not necessarily integers, and you're going to have an infinite numbers to put in, and you're going to be there for an infinite amount of time. So counting really isn't going to be the right way to do this, doing case we're counting. We're going to draw a graph for this problem, actually, where before I do that, we basically have to say the number a plus the number b is greater than 4. That's basically what we need. We need to find out when that's true, where a and b are between 1 and 4. That's basically what we need to figure out. And so to solve that, I'm going to actually graph it. So if we have 1 over here, 4 over here, 2 over here, 3 over here, and then this over here, we're going to graph the point where a plus b actually equals 4. And then we're going to take all the stuff above that, because that is a solution to our problem. So this point over here is 1, 1, so 1 plus 1 is 2, which is not equal to 4, so I need to move on. 2 plus 1 is 3, which is not equal to 4. 1 plus 3 is equal to 4, so that right there, that's going to be on part of my line. Now, if I say 2 plus 2, that's also going to equal 4. And now, there's going to be no more on this line, no more on this line. 1 plus 3 equals 4. That's our line over there. Supposed to be a line, sorry about that. And so that right there is where a plus b equals 4. And the question says, what's the probability that it has a sum greater than 4? So I basically need to take all the points above this. So for example, the point 33 is in here, and that sum 3 plus 3 is greater than 4 because it's 6. So now I need to find out the probability when given this grid of selecting over here. And to do that, I'm going to use complementary counting. So I can figure out the area of this, and then since I'll call this area C and this area D, we know that the area of C plus the area of D has to equal 100% of the area, or 1. Therefore, if I subtract C on both sides, I have D equals 1 minus C. So I'm going to find the area of this and then do 1 minus that. So I see that it's a triangle with a height 3 and a side 3. So it's going to be A times B over 2, or height times length over 2. So that area is going to be 9 over 2, 3 squared over 2. And now the area of D is therefore going to be, or I shouldn't say, it equals 100% of the area, which is 16. Sorry about that. Because it's a 4 by 4 grid, so 100% of the area is 16. So now I need to find out what 16 minus 9 over 2 is, and I'm going to convert that into a fraction. Which is going to be 23 over 2. So now, given the area is 16 and the area of that is 23 over 2, what's the probability of when selecting a random point? I have the point in there. Well, that's just going to be the good options over the total outcomes. So the good ones, that's going to be 23 over 2, and divided by the total, which is an area of 16. So now our answer is going to be 23 over 2 times 1 over 16, which equals 23 over 32. Thank you very much for watching, and goodbye.